Good afternoon, everyone, and welcome to week 11 tutorial. So, in this tutorial, we'll try to solve the exercise that is around hypothesis test for independent and dependent data. So, I will suggest you to just download week 10 tutorial exercise because the week 11 tutorial exercise is on the hypothesis testing for proportion. So probably we have not covered in the class the proportion. So we'll go ahead with the week 10 tutorial exercise. Just download it from the Moodle, and then so there are like it's a kind of mixed exercise. I mean, I think the exercise 1, 2, and 3 we will use it. We'll do it exercise 1 and 2 using the hand. We'll do it manually, and the remaining exercise like 3, 4, and onwards we'll do it using the Excel sheet. So I will suggest you at the meantime, you just download the Excel sheet which is there for week 10 and 11. There is an Excel sheet on Moodle. You just download that one as well. Let me show you that file. That is this screen. Okay. So just download this one, week 10 and 11 data. It is in under the week 11. So we'll try to do the week 10. We'll try to work on the week 10 data. That will be a part of the hypothesis testing for the dependent and independent groups. So download this one, week 10 and 11 data. The Excel sheet is there. And let's go through one by one now. The exercise number 1. Analyze this question. All these cases are either on the dependent or the independent data. So in the last time we had a lecturing section lecturing on the independent and dependent data. We have seen through the experimental design, experimental setting. We have understood the differences between the dependent and independent samples. What do you think? The exercise number 1. Researchers, they conducted trials to investigate the effects of color on creativity. I mean, is it a red color which leads to more creativity, or is it a blue color or blue background? Both groups are random samples from population that follow normal distribution. And keep in mind, if it is a different groups, you need to understand that they won't having it won't be having it won't be having equal variances. So with unequal, not equal variances. Subjects with a red background were asked to think of creative uses of the wick, and the same way the other subjects has been asked the same way. And the responses were scored by a panel of judges, and results from the scores of the creativity are given below. So the red background, the number of sample respondents were 35. Blue background, number of respondents were 36. And the respective mean value for the red and the blue is given. And along with that, capital S. It seems like over here it's a small s. So keep in mind, even if it is a small s or the capital S, it's both are the same thing. It's like standard deviation for the sample. Since we are talking about the two different samples, so these are the standard deviation for the samples. Researchers make a claim that colors does not affect creative tasks or creativity in a human being. So you need to test the claim that there is a difference between the mean creativity scores for those with a red background and the mean creativity scores for the those having the blue background at at 1% significance level. I mean, alpha is 90. What is the alpha value here? It's a 0.01. So think about how to proceed with this one. Clearly, it is a two different samples they are talking about, N1 and N2, N1 with the red background, N2 with the blue background. So clearly, this is the case of more than one sample. Do you think it's a case of independent or dependent the samples? Do you think the red background respondents and the blue background respondent, is there anything which is common, or is it independent? So they are independent over here. Clearly, this is the case of independent data. So let's proceed with the how to solve this. Right. Okay. So we'll go through a step-by-step process and try to solve this one. So clearly, this is the case of independent sample. I mean, these two samples with the red background and white background, these two samples are not matched or pair. So it's an independent sample. So that you need to keep in mind. So both the samples, think about the requirement. Both samples are independent. Both samples are random. It is clearly mentioned. It is also mentioned that both the populations, it follows the normal distribution. What about sigma 1 and sigma 2? It's unknown. So sigma 1 and sigma 2, if it is unknown, it is clearly the case of T statistics. And it is clearly mentioned that it's an unequal variance. Assume that the population is normal and with the not equal variances. So this is clearly the case of separate t-test. What we understood, separate t-test. So this sum, exercise 1 is clearly the case of separate t-test. What is the second stage? To frame the null hypothesis and alternative hypothesis. So can you do it on your paper? What could be the null hypothesis? H naught could be, what is the claim? You need to see, test the claim that there is a difference between the mean value of both. So claim is there is a difference. So that is the alternative one. So what is alternative? There is a difference. I mean, mu1 not equal to mu2. That is the claim. I mean to say, you can rewrite it, mu1 minus mu2 not equal to 0. That is the claim, that mean values are not equal. So what is the alternative hypothesis then? Mu1 minus mu2 equal to 0. Or if you wanted to have more, you wanted to write more precisely, then what you will do, instead of writing 1 and 2, what you will write? You will denote it with the red and blue. So mu red, mu blue, mu red, mu blue, mu red, and mu blue is equal to 0. Both are okay. What is the next step? I mean, this is the second stage. Third stage is find out alpha value. What is the alpha value?
0.01.
0.01. And then finally, you have to find out, the very important step is find out the t-stats using the formula. You remember x bar for red minus x bar for blue minus mu red minus mu blue divide by, what is the formula? Standard deviation SR squared by NR or N1. I'm simply writing N1 plus SB squared by N2 and whole root square. Can you solve this one quickly? What is given? 3.39.
Please show us the board.
Any doubt? Please ask.
Show us the board.
Better?
Yeah.
I'm sorry, it's a bit slightly tint. It's not purely vertical. It's slightly, I'm not having the exact setup which I'm supposed to be. It is there in the university, so I just got the whiteboard, but it's not a properly fixed actually in the frame. So that's why it's not 100% vertical. It could be a kind of reflection, but try to maybe. Yeah. So you have all the data, 3.39 minus 3.97 minus 0. Find out the value. I think, where is the question over here? Okay. So 3.39 minus 3.97. Okay. And then standard deviation 1 and 2. So red is 0.97, 0.97 square by N1. What is N1? 35 plus 0.63, 0.63 by N2. N2 is 36. Quickly try to see what value is coming for the T stars. Anyone? Try to find out the value for T stars.
Sir, I just have a question. Where did 0 come from?
Over here?
Yeah.
This one comes here from a null hypothesis. And keep in mind, it will be always 0. Because the
okay, always.
Will be always 0.
Okay, thanks.
Try to solve this sum and let me know what values you are getting. And remember, we have the different formula for getting the degree of freedom in this case. No? No. What is the formula? Yeah, we have the different formulas for getting the degree of freedom as well. So let me open that slide for you then. Meantime, just try to calculate and see what value you get for the T stats. And we have only two manual, two exercises for today, which we have to do manually. Otherwise, others we have to do. Rest of the exercise we have to do using the Excel. Sorry, I changed devices. So putting my attendance. That's okay. Let me open the slide. We change slides. Even the week.
So, do we have quiz today?
Quiz is on the Monday. Yes, I have already uploaded the quiz material.
I thought we have today.
No, we never. Always we conducted the quiz on Monday, right?
All right. Thank you.
Yeah, so we have on Monday. Tutorial class is like more like a kind of exercise, sums and all. No much theoretical discussion. It's on the practical, the real sums we are trying to discuss. So over here, where is the formula? Yes, over here. Actually, I'm trying to apply the same. What is the T starts value? Anybody? Is it a minus?
I'm getting -2.97895, but I'm not sure.
Yeah, I got the same.
You also get, okay, good. So two students, I'm sure like it's right only. So what is the T stats value you are getting? Minus 2.978. Okay. And then try to get quickly the DF value using this formula, degree of freedom, DOF. Find out DOF, degree of freedom, DF, using the formula which is there in front of your, this is a bit, S1 square by N1 plus S2 square by N2 whole square. It's difficult to write, so it is there in front of your screen. So just apply and find out the degree of freedom. If any one of you get the degree of freedom, just let me know so that we can proceed further. What is DOF value? Anyone? Then the next step will be DOF, and then finally we'll calculate the P value.
I'm getting 45.85.
Okay, 45.85. Anybody else wanted to confirm? Let me wait for someone else. So according to you, if you round up this one, you will get 46. Since it is more than 0.50, 0.85 is more than 0.50, so you need to round up this digit and this to the nearest whole number. So according to you, degree of freedom is 46. Just wait for if somebody else is confirming, otherwise we will proceed. Others, anybody is trying to get the degree of freedom?
Yeah, I got the same.
Exactly, 45.85.
Yeah.
Okay, so I'm going ahead with the 46. Thank you so much, both of you. So degree of freedom is 45.85, 46. So this is the degree of freedom. So it's not an n value. So go ahead with the table now and see what is the probability value, P. So next stage is to find out the P value. So quickly go through the P table. Okay, I mean T stats table. So you have degree of freedom 46 in front of screen. Yes, 46 is the freedom, and the value is how much it is. If it is a negative, so just think about in the positive side. So 2.978. Make it as okay, 2.978. So
Sorry. Is this table in Moodle?
yes, this table
Oh.
is on Moodle under the announcement.
Okay. Okay. Thanks.
So where it is close to 2.978. So 2.978. So probably over here 2.687. So let's see what value it is coming on the top. So 2.678 is 0.005. So probability you will get 0.005. And what do you think? This is the case of one tail or two tail? With the table, I got, yeah, this is the case of two tails. So with the from the table, I got the value 0.005. That is the closest one. And since this is the case of two tail, here is that is mu r not equal to 0. So it's a two tail test. In that case, in order to get the p value, we have to multiply by 2. 2 into 0.005. So how much it is? 0.01. And what is the alpha value? 0.01. So again, you need to get the critical value in this case. So go back to the table once again. You know why this is happening? Because 0.01 and your alpha value is also 0.01. So there is a kind of, it seems like there is a confusion. So for that, you need to look at the bigger picture. So now I'm erasing here and I will see the critical value. What is the t value at the critical point? 0.005. Can you tell me, anybody? What is the critical value is coming? Our t value is 2.978. But look at the critical value at 0.005.
2.6870.
Yes, it was, yeah, 2.6870. Very good. 2.6870. 2.6870. And that gives the area of 0.005. Try to understand this step is very important. Let others to understand. Okay. The critical value is at this 0.005 using the t stats. The critical value is 2.6870, and this side it will be minus 2.6870. But what critical value we are getting? Minus 2.978. So 2.978 will be somewhere right to this critical value. This is the critical value. This is the critical value, and we are getting t stats value 2.978. So that is somewhere right to this point. So this point is 2.978. And if you could remember, these two are the area of non-rejection, and these two outside is the area of rejection. So outside is, these two are area of rejection. This is the area of rejection, whereas inside both are area of non-rejection. We already know that. Area of rejection outside and area of non-rejection. So the t value falls under area of rejection. That means we must reject null hypothesis. So what is the conclusion? Stage number 6. Step number 6 will be, since reject, what will the, yeah, in steps again will be reject H naught. So reject H naught means, what was the null hypothesis? The null hypothesis was mu, there is no difference. Mu r minus H naught was mu r minus mu b equal to 0. That was our null hypothesis. So we have not received any support for this. So we got a support for alternative hypothesis. So reject H0. That was the conclusion. Any doubt here? Any doubt? So important thing is here, like you need to see the critical value, because 0.05, which we were getting using the traditional way, our own way, was contradicting with the alpha values. That's why we try to see the complete picture. So in the complete picture, we saw that it falls under the area of rejection, the t value. It was t value, we got 2.978 minus value. So minus means positive side, 2.978. It falls under the area of rejection. So just reject H0. And that's what is the claim, like either accept, either reject H0 or not reject H0. I think the exercise number 2. Is same as the exercise number 1. Is there anything different? You want me to go ahead with the exercise number 2, any one of you? Because it looks same as exercise number 1. Read the question, exercise number 2. Read the question, exercise number 2, and do you think you will be able to solve this just like the exercise number 1? We know that the mean weight of the males is different from the mean weight of female. So clearly it says that it's a what? Independent data, independent sample. 2 samples, but they are not dependent, because one sample is for the male BMI and the second one is for the female BMI. So again, this is the case of, and it is given that the random sample, and assume that the population follow the normal distribution with not equal variances. So again, this is the case of separate t-test. So for that you have given, what are the things which are given to you? N1 and N2, X1 bar, X2 bar, S1 bar, S1 and S2. And test the claim that there is a difference between the BMI scores of males and mean score value of BMI for the females at 5% significant level. So do you think you will be able to solve this one, or just try to do it fast? I want any one of you can, could you do the calculation for V fast, the degree of freedom? T stats I have calculated, but can anybody do the calculation for the V, degree of freedom, for the exercise second? Just do it quickly. It won't take much time. So exercise, okay. So exercise number 2, I'm trying to formulate the null hypothesis and null and alternative hypothesis. So what is H0 here? In the case of exercise 2, so H0 will be mu value for M male minus mu value for female equal to 0, whereas alternative hypothesis HA will be mu M minus mu F not equal to 0. Since it is not equal to 0, clearly the case of two-tail test. Says alpha value is given. Alpha value is given 0.05. You need to find out at the 5% significant level. So alpha value is given 0.05. Find out the t value, t stars. This is again the case of separate t stars, right? So what is the t statistics? Use the same formula and you will get 28.44 minus 26.60 divide by 7.39 whole square by 40 plus 5.36 whole square by 40 all square root. You will get the T starts value 1.275. But I want somebody to do calculate the DF value, degree of freedom, using the formula. Meantime, if anybody is having any doubt, please ask. Stop me any point of time, at any point of time when you think that anything is not coming to you in the way it's supposed to be. So just let me know if anything is not clear. And I want somebody to tell me what is the DF, degree of freedom. Good thing is if you're doing more and more practice using the calculator, probably your speed will be, you will get like your speed will be more enhanced, and you will be able to solve the sum in this list span of time. So it's good, like do the practice. And that is the idea during the exercise or the tutorial, is to have more and more practice. We have only two exercise which we are supposed to do manually. Otherwise, the rest of the exercise for today is using the Excel sheet. So take your time, but just let me know. Did you get the T stat 1.275? Anybody can confirm this value?
Yeah.
Okay, good. And just let me know the degree of freedom then. Remember, the next quiz, which is on the hypothesis testing, probably there will be no question on the, I mean to say, the more than one sample. So that just keep in mind for the quiz. I can't forcefully put all these things in the quiz. So just if you are like you understood well the one sample size, mean of one sample, single sample mean for the hypothesis testing, that will be fine for your like quiz 6. Did you get that?
Wait, what do you mean? So
More than one sample will be not a part of your quiz 6.
okay, so pretty much it's just like week 9 then.
Yes, so it's only the single hypothesis testing for the single mean.
Okay, so single mean.
Yes, single mean.
And is that it?
Yes, and apart from that, the normal understanding of the hypothesis testing. I mean, this sort of question will be not, which we are covering today, will be not a part of your quiz.
All right. Okay.
Sir,
Yeah, please.
sorry, I have a question. I was in the PowerPoint of week 10. So the test statistic equation, yeah, it's the same, but how come in week 10 it's saying that the degree of freedom, you get it by calculating n minus n1 minus 1, n2 minus 1, then you choose whatever smaller.
I didn't get you. Which slide you are talking about?
In slide 21 of week 10 PowerPoint.
Yes. Yeah. Okay. Let me open that one. Yeah. Yes. What is the question here?
So is this like an updated version?
Yeah, this one is the updated one. Okay.
Okay,
You got
okay.
the older one. Okay.
Yeah.
Okay.
Okay.
Just delete that one because this is the proper way.
Okay. Thank
I
you.
don't know, like somebody last term, somebody else taught to the NIC, and
Okay.
they simply consider he or she, I don't know, but they simply consider n-1. So that was the wrong one.
Oh, okay.
So I added this one.
Okay.
So just go through the added one, the updated one all the time.
Okay, thank you.
So and any one of you, did you get the value of DF, degree of freedom, using this formula? Let me know what is the value you get for DOF, degree of freedom.
Um, 71.13.
Pardon once again.
71.138.
21.
70. 71.
Oh, 71. So, okay.
0.138.
8. Okay. Anybody else? Could you confirm? 71 looks yeah, reasonable, because N1 is N2 is 40, N1 plus N2 is 40, so it will be below that. Remember, it will not more than addition of these two. That's what I'm just cross checking it. So it should be 40 plus 40 less than it must be less than 80. The degree of freedom for size n always n minus 1, so it is low. It should not be, never be the higher one. So remember, if by mistake if you are calculating the degree of freedom somewhere 89 or 81, think once again that something is wrong in the calculation, because it should not exceed 40 plus 40 80. It should not exceed. That is a kind of cross check. Did you get that?
So the two ends added together, it shouldn't exceed that.
Exactly. Degree of freedom is always less than that value.
Okay.
That is like, you need to analyze, you need to perceive in such a way that it should never. So by mistake, if you did some calculation, it is coming out, drop, do it again. So just I wanted to confirm, is it like 71.138 is the right one? I'm assuming that this one is the correct one because it's lower than 80, so I'm happy with, go ahead. So 71.138, if you make it round up, it will be degree of freedom 71. Okay, it won't be 72 because it's 138. So if you make it as a whole number, you will get 71. So what is the next step now? Open up the T-stats table and see what is the probability value. Once again, I'm repeating that whatever formulas you think that it will be required, keep yourself ready with those one in your system. Although I have provided in the question paper itself at the end all the list of all the formulas, all the tables and all, but just for a precautionary thing, I will be not there in the exam for moderating you, because I have unfortunately I have another scheduled class at the University of Newcastle at the time of final exam during that duration. So I won't be available for moderation. So please be careful. So whatever formulas, tricks and everything, if you think is required, be ready, keep yourself ready with that. So 71, degree of freedom 71 over here. I have given you two different formula like table for the T-stats. So probably in the exam, I have given you only one. So it's up to you. Even if it is not given, you can use the first formula also, first table also, and take the approximation. It will be okay. So 71, degree of freedom is 71 here, and T-stats value. So degree of freedom 71, and T-stats value is 1.275. So let me see, 1.275. Yes, 1.2936 is the closest one. Okay. So what is the corresponding value? P value? Anyone? 2 points. So second row, second column. So 1.2. So 0.10. 0.10. And since it is the case of, this is the case of two-tailed test. So what we have to do? What will the p value in the stage number 5, p value will be 2 into 0.10, that is 0.20. Okay. So now stage number, okay. So p value is 0.20. P value is greater than 0.05. 0.05. What is the conclusion in the stage number 6? Since p value is greater than 0.05,
Don't reject.
we will reject what? Oh, okay. You said don't reject. Yes. Don't, not, yeah, exactly. Not reject. Not reject the null hypothesis. Not reject H naught. So, what will be your final conclusion? There is a no mean difference in the, so we can say there is no mean difference. Writing at the bottom, we could say there is no mean difference between the mean value of male and female BMI, isn't it? So we should not reject H naught because the p value is greater than 0.05. So there is evidence or empirical enough evidence that there is no mean difference between the mean value of male and female BMI. Between the value of, okay, there is no mean difference between the value of male and female BMI. Any doubt? Or everything is clear? So we'll do the sum, as I said, exercise number 3, if you could read, exercise number 3, 4, and 5. We have 3 different data set for this 3, 4, 5. So that I will do using the Excel sheet. What about the exercise number 6? It's a theoretical question. Exercise number 7 and 8 we will not do because the exercise number 7 and 8, if you could see, this is the hypothesis test for the proportion. It's 8% of the brown or 13%. So it's something in percentage. So if you see, if you read the question number, exercise number 7 and 8, it is the clearly this is the case of hypothesis testing for the proportion. So we will not cover the proportion. I want you to do the exercise number 6 now first. And then we will do the remaining 3, 4, and 5 using the Excel sheet. So let's go through the exercise number 6. Exercise number 6, question number, what it says that, what is the question? You need to specify whether the parameter of the interest is one mean, the mean of pair differences, or the differences between two means. And the second one is, write the null hypothesis and alternative hypothesis for both A and B. So let's have a discussion for A and have a discussion for B. Nutrition. Okay, jump to the question 1, the exercise A, 6A. Nutrition trends have changed over the years, and this may affect growth. Researchers, they wanted to know whether the mean height of 25 years old female is the same as the mean height of 45-year-old female. What do you think? Is this the case of one mean, or mean of pair difference, or the differences between two mean? Out of these three, which one is this case? And anybody can speak. So tell me, is it a case of independent or dependent, or one mean or more than one mean?
It's independent.
Yes, because what is the reason why it is independent?
It's two separate groups, male and female.
No, it's not a male and female. It's both are female.
Oh, I'm sorry. Different age category.
Exactly. On the basis of age. So we can say that this study is independent, as we have two independent groups. One is the female of the age of 25, and second one is female at the age of 45. So this is clearly the independent case. And the second one is write the null and alternative hypothesis for this sum. So I could write here. So the study is independent. Study is independent because we have two different groups.
So, sir, is it like the difference between two means then?
Yes, difference between two means. Yes.
Okay.
So this study is independent because we have two different groups. One is female 25 and female 45. And based on that, can you formulate H naught and H alternative? What will be the H naught? So H naught will be null hypothesis will be there is no differences between the mean value of female age of 25 and female age of 45. So one could write in such a way, mu F is female 25 minus mu again for female F is 45. So the null hypothesis is there is no difference equal to 0. The moment you formulated the null hypothesis, easy to formulate the alternative hypothesis. Mu F 25 minus mu F 45 not equal to 0. And clearly this is the case of two-tailed test. So the part A is the case of two means, differences between two means, and they are independent. Can you go to the next question? Part B, 6. I think you should take your own time to understand part B. So, what do you think? You plan to fly from Sydney to Bali and have a choice of two flights that leave at about the same time. And you wanted to know how many minutes late each flight was for a random sample of 25 days. You want to know whether one flight has a higher mean for the number of minutes the flight is late. So the question is, does this case is for one mean? Clearly no. The mean of pair difference or the differences between two means? Decide. Is this a case of pair difference or the difference between two means? So it's a, what do you think? It's a dependent one, right? But we can say that part B. But we can say that for the part B. So this study is okay. So the scenario is, this scenario is what? Independent or dependent? It's a dependent one. This scenario is dependent one. Because this scenario is dependent one. Flights are leaving the same airport, Sydney, approximately at the same time, because flights are leaving at the same airport at the same time. At the same time. So it's a dependent one, right? This is a dependent. And then what is the second question? Formulate the null hypothesis and alternative hypothesis. So remember, the matched one, we have what we have seen, how to formulate the null hypothesis and alternative hypothesis in terms of differences. Remember? So what should be the null hypothesis then? There is no difference between the two flights. So you could say mu d is difference equal to 0, or mu d not equal to 0. You can't write the way we have written for the part A. So difference is mu d equal to 0, mu d not equal to 0.
Sir, sorry, I missed it. Is it paired difference?
Exactly, the pair different. Yes, exactly.
Okay, thanks.
It's a paired one, like same, they are leaving at the same airport at the same time. It's a paired difference.
Okay.
Trying to see. Again, I'm repeating the same thing. I have uploaded a very good file, chapter on the hypothesis testing on the Moodle. So I will suggest everybody just go through that. There are lots of good questions. It's a solved examples. There are so many exercises with the answers are provided in the same chapter. So it help you in better understanding, and probably in the coming quiz also there could be a kind of some sort of questions will be, you know, on the similar pattern. So just if you feel that you are not confident with the hypothesis testing, or you wanted to have, even if you are confident but you wanted to have dig a bit more, please read that one. That chapter is already uploaded in the Moodle. So please go through that. So exercise number 1, 2, and 6 we have covered. Now we have remaining exercise 3, 4, and 5. So that we will do using the Excel sheet. And I suggested you to download the Excel sheet in your system. so that we can work together. So where is the question exercise number 3? So let's go through exercise 3 first. So let me open the Excel sheet in front of you. Where is that Excel sheet? I strongly suggest you not to use the Excel sheet for exam during your exam. Do it manually because we have seen that there is a like slight differences in terms of the t values, in terms of the p values. So probably I mean to say that the answers which is ready for your NTEM exam will be based on the manual calculation. So just take a kind of precaution. Should not jump to the Excel sheet for solving the exercise. Excel sheet will take less time, that I know, but sometimes that there is a like differences with, in the result, minor differences, and maybe you lose your marks. So hope that is clear for you. So now I have 3 different Excel sheet, like one Excel sheet containing exercise 3, exercise 4, exercise 5, 3 different data sets. Exercise 3, 2 different data sets on, one is for 2 different sample, one is from Pennsylvania and second one is New York. Second one is for male, female and differences, and third one is firstborn, secondborn and differences. So 3 different exercise we have, exercise 3, 4 and 5, and we will do it using the Excel. Read the question, exercise number 3. So the observed values are from the random sample of baby teeth from 2 different states in US, Pennsylvania and New York City. Assume that the population is it follows the normal distribution and separate. This is clearly a case of separate t-test, since we are not doing it manually. So you keep in mind on the Excel sheet which tools we have to, which is the appropriate to solve this one. Test the claim that there is a difference in mean amount of strontium-90 between the 2 cities at 1% significant level. I will suggest you to, while you will do this one on Excel sheet, just let me know in formulating the null hypothesis and alternative hypothesis. What, in this case, the exercise number 3, what do you think? What should be your null hypothesis and what should be your alternative hypothesis? So what is the question here? Test the claim. Test the claim that there is a difference in mean amount between the 2 cities at 1% significance level. So alpha value is given. Alpha value is given 0.01. And what is null hypothesis H naught and what is alternative hypothesis HA? Could you able to write in your paper what is null hypothesis and alternative hypothesis? So 2 different cities. So one is Pennsylvania and second one is New York. So H naught is mu p minus mu New York, I can write as a n. This equal to 0. Alternative hypothesis is there is a difference between these two. So mu p minus mu 1 not equal to 0. And since it is not a case of, clearly it is, what is the question? Since the claim is there is a difference or there is not a difference. So clearly this is the case of two-tailed test. Alpha is given. So we'll try to find out t stats and p value using the Excel sheet. So what is the t stats? Clearly this is the case of separate variance, but we will not apply we will not do this one as a like manually. We'll do it, and the p value both we will get it from the Excel sheet. So try to get the Excel from the Excel sheet these values. Okay, over here. Can anyone remember what tools, how to proceed? Go to data analysis, and then you have t-test. Clearly this is the case of t-test, two different samples from two different cities. What do you think? Out of three different options for the t-test, which one is appropriate here? Is it a paired two sample of means? Is it a paired one? No, two different cities. So clearly the first one is not the option. The second one is two sample using equal variance. Anywhere it is mentioned it is equal variance, probably two different set of data. So it will be an unequal variance. So you have only one option which is remaining, the t-test, two sample using, assuming unequal variances. So it's a separate variance. Unequal means separate variance. So just pick, choose that one, t-test for the two test, unequal variance. Okay. And then you have to provide the link for the data. Remember, so variable one range, I'm including the label also, the name of the city. For the second variable, and I will click here the labels I have added. What is hypothesized mean difference? Yeah, please ask Betty.
No, sorry, I clicked it by mistake.
Are you able to see everything on the screen?
Yeah, we see the Excel sheet.
Okay, okay. And are you guys like able to follow? Like everything is clear, right? So what is the hypothesized mean difference? Check out your mean H naught. You must provide the value of hypothesized mean difference. What is H naught? The mean difference is 0. I mean to say mu p minus mu n is equal to 0. That is hypothesized mean difference. You must provide the value 0. Then what is the alpha value? By default it will be 0.5%, but in this case alpha is given 99, right? 1% significance level. So what is the alpha value here? 0.01. So you need to correct it. I wanted to have output in the same screen. For that, anywhere at the free space, and then finally okay. You see output, what came out as in terms of output, two different cities, mean value for the Pennsylvania and the New York. The same thing is for your variance for both the city. Observation is 12, 12, and 1 is 12, and 2 is 12. What is the degree of freedom? Although like we do all these things manually, and then it's lots of calculation involved, but you see here the degree of freedom is 16. That is lower than 12 plus 12, or 24. T stats, if you could have applied the manual way of calculating T stats value, you could have get the 3.26. So what is the T value you are getting here? T stats is coming 3.26. And then this is clearly the case of two-tail test. So you have to see the p-value for the two-tail, not for the one-tail. Although the one-tail and two-tail, it's just a 2 times of the one-tail. So what is coming out? 0.0048. P-value is 0.0048. Isn't it? 0.0048. Now, Excel sheet is not giving you the final decision making, right? It gave you all the p values, it gave you the data on t stats and everything, but it is not suggesting you that you have to reject or you have to not reject. So, as a researcher, as a student, statistics students, you have to take that decision. So p-value, is it a p-value less than alpha or p-value is greater than alpha? So clearly the p-value is, in this case, p-value 0.0048 is less than 0.01. P-value is less, H naught must go. I mean to say, what is the conclusion here? Should reject H naught. Reject H naught means this one got rejected. I mean, you found the support for, so you could say that there is a difference in the mean value of teeth of the sample of Pennsylvania and New York. So that is the conclusion over here. Reject H naught. I mean, we got a support for the differences. We can't say that both the sample mean values are same. So we got a support for alternative in this case, since p-value is less than 0.01. You try to see that the Excel give you everything so quickly. Let me know, is there any doubt here? So what will be your conclusion over here? Since p-value 0.0048 less than 0.01, so we reject H naught and conclude that there is a mean difference in stormium 90 between the two different cities, Pennsylvania and New York. So there is a significant difference in terms of strontium 90 between these two cities. Is that clear? Are you able to run these tools on the Excel sheet, or does anybody face any difficulty in running the Excel sheet?
Yep, I'm able to do it.
So you found it on your Excel sheet?
Yes.
And value?
Yep.
All good, all good.
Followed.
That's good. If there is no question over here, then quickly move to the next exercise. Exercise number 4. Take your own time to understand the question first, and then look at the data which is given to you and think about like how to proceed further. This case is, the exercise number 4 is on a couple, male and female. So start thinking, do you think these observations are independent or dependent? If it is a dependent, is it a matched or paired? I mean, both are the same. I mean, is it like the case of paired or matched? So observations are on the number of words spoken in a day by each member of 6 different couples. The data are randomly selected from a population of couples, assuming, yes, it's a separate variance. You have to assume that. Assume the population follows the normal distribution with unequal variance. So you have 6 different couple, male and female, and number of words spoken in a day by each member. And then on the basis of that, you have 3 different questions. The first one is, test the claim that there is a difference between the mean words spoken in a day by each member of the couple at 5% significant level. Part B, calculate a 95% confidence interval for the mean difference in words. Remember the word, the CI estimation for the mean differences. I mean the differences in the words. We have to calculate CI. And the part third is, does the 95% CI confirm the decision made in hypothesis test? I mean, did you get the sense like there are different ways of supporting the claim? The first one is either you can do it by hypothesis testing. A second way is even using the CI estimation, you can make this kind of you can have a support either for the rejection of null hypothesis or not rejection of null hypothesis. There are different ways. These two different ways you can make a similar sort of claim using both the ways. Either you can have a straight way hypothesis testing, take a decision. Otherwise, even if you are not using the hypothesis testing t-stats formula and all, if you are able to do it, you are able to take the decision based on the CI estimation. We'll see that in this. So what is the important here? Well, the important thing is just formulate the null hypothesis and alternative hypothesis. So this is the case of 4A. So clearly this situation, the scenario is a matched or the pair design. A couple consists of male and female. So it's a kind of paired one. So it's a case of dependent one. It's a pair design. The male and female are a couple, therefore the number of words are dependent. Requirements is fulfilled, samples are dependent, randomly selected, and normal distribution. So what is important here? After meeting the criteria, try to formulate null hypothesis and alternative hypothesis. Who will tell me what will be the null hypothesis and alternative hypothesis? Let me know. Who can suggest me the null hypothesis and alternative one? Alpha is given. I'm writing here the alpha is 0.05. Who will suggest me what is the null hypothesis and what should be the alternative hypothesis in this case? I want somebody to volunteer. It's easy. This is the case of, we have done similar sort of question. This is clearly the case of paired one, paired design. The dependent one. So what will be the null hypothesis and alternative hypothesis? How could you write this one? Can we write like this? H naught mu for male minus mu for female equal to 0. Alternative hypothesis, mu male minus mu female not equal to 0. Is that okay? Is that okay? Okay, let me have a kind of quick code here. I have polling, but again, I don't know why I'm not able to run it. Not this one, polling second. Okay. Yes, the H1 is correct. Okay, there is a polling question in front of you. I want you to just have a voting. For H1 and for H0 and HA, I formulated over here on the screen. You notice that. Let me see how many of saying is it the correct or is not correct. Read the question at the meantime. If you have a confusion, like what if I'm asking that what read the case like that is the claim that there is a difference between the mean words spoken in a day by each member of the couple at 5% significance level. Do you think they see? I know with the practice only it will be more and more clear with the time and with more practices. But those who are saying yes, they are considering the male and female as a separate identity, and they are treating this example, this exercise as a independent data. Those who are saying yes to this answer, this question, they're treating male and female as independent data. Unfortunately, because this is the case of dependent data, paired one. So in that case, you should not write in a way like mu m, and we do these things in the case of independent, two different independent sample. We never do this sort of, we never do write this notation in the case of paired or dependent data. We never did that. I know the things will come with the time, but try to see those who are saying no, you are right. Let me end this polling. and then rewrite the another way. What I'm saying that there is another version like mu d, mu h naught equal to mu d, mu difference. There is no difference in the male and female spoken. H alternative is there is a difference. So one set of hypothesis is here, another set of hypothesis is here, and this is the clearly the case of couple. It's a dependent data. So this one is right and this is probably wrong. Because this is the case of couple. See, at the beginning you need to analyze like, is it the case of independent or dependent? So you already took the decision, it's a dependent one, it's a couple. For a couple male and it's a dependent one. So you took that decision dependent data. So in the dependent data, you always look for the differences. The training, before the training, after the training, the performance of the marks. You take the differences and you see there is no difference and there is a difference. So the notation gets changed in the case of dependent data. So this is the case of paired or dependent data. This is the notation. But this is the case when you treat male and female as a single separate sample mean. So over here, this is not the case. So you should get rid of this sort of notation. This is not the correct one. This is the correct one. If you have any doubt, you can ask. Otherwise, I will proceed with how to solve this one using the Excel sheet. But remember, this is the right notation for this sum. Open your Excel sheet now and go to the exercise number 4. Okay, so you have the, that's why you have the differences over here, male and female and the differences. So just proceed further now. Go to the data analysis. So in this case, t-test, which one? This is not the case of 2 samples, so no need to worry. No need to have a kind of imagination of independent data. So 2 samples, it's a paired 2 sample for mean, paired one. So select the first one. It's a paired one, 2 sample for the means. Okay, range 1, give male. No need to have inputs couple 1 to 6. That is just notation for us, like how many couples this experiment has. Range 2, female. So no need to put differences over here. This is for the next calculation, part B. What is the hypothesized mean difference? Mu D. What is the hypothesized mean difference? It's a 0. Put it 0. I have included labels, male and female, so I'm ticking. If you have not included, don't tick. What is the alpha value? Is it a 0.001 for this sum, or you need to claim at the 5% significant level? So it's a 0.005. Output range, I want it to be here in the same, okay, over here. Everything is done, okay. Now in front of you, you have all the output. Okay. So t-test for the paired 2 sample of means. 2 samples are there, 2 different means are there, but it's a paired one. For a couple, it's a male and female. We know that. So it's a paired one. You can't think about it, because the way the question has been framed, it is a paired one. One could frame it in the different way. That can you claim the test for a difference between mean, what is spoken by male and female at 5% significant level? Then in that case, it could be a kind of different proposition, story altogether. So it totally depends on the what kind of questions has been framed by the researcher, by the statistician, and what is the purpose of conducting or doing this exercise. It totally depends on that. So what is the t-stats value? So for this one, what is t value? T is coming 2.578. 2.578 with the degree of freedom 5. What is the sample size? 6 plus, so it's a 6, yeah. So you see here, it's a less than 6. It's a 5. Clearly, this is the case of two-tailed test, mu d not equal to 0. So two-tailed test means, what is the p-value for two-tailed? 0.049. So what is the p-value? I'm writing on the top. P-value is coming 0.049, isn't it? 0.049, right. And what is the alpha value? Alpha value is given 0.050. See, almost equal, but still. So from here, go through the whiteboard now. So from the Excel sheet, I got the p-value 0.049. So very close to the alpha value 0.050, but still there is a minor difference. So p-value is 0.049 is less than 0.050. So p-value is less, H naught must go. So we will reject our null hypothesis. Rejecting null hypothesis means this is not working. Alternative. So alternative says there is a difference between the number of words spoken by male and female in a couple. So on the basis of that, there is exercise number 4. So you will reject the null hypothesis because alpha value is, p value is less than alpha. You will reject the null hypothesis and then you will say we reject null hypothesis H naught and conclude that there is a mean difference. There is a mean difference in words spoken by male and female in a couple. There is a mean difference in words spoken by male and female in a couple. That's it. The next question, part B, we have not completed. So this is the part A. Part B, calculate the 95% confidence interval for the mean difference in words. How to proceed with that? CI estimation for the mean difference. So in that case, we have already calculated the value of difference. Remember, see the column A is the difference between the male and female words spoken. So the first one is the difference between 5198 minus 5638, 440. Similarly, you have for all the 6 couples. So you want to find out the margin of error. Remember, in order to calculate the CI estimation, what you want? X bar, mean, and margin of error, E. So using the Excel, you can find out. So now the second stage for the part B, go to the data analysis and then go to the descriptive statistics over here. Then press OK. Input range, only they're asking for 1. And this time I will give differences because read the question once again. They calculate the 95% CI interval for mean difference in words. So take that column, differences column. I have selected labels, click labels. Output range, I wanted to have the same somewhere over here itself. I wanted to have summary statistics. Yes. I wanted to have confidence level of mean. This is the margin of error. So yes, I wanted at what 95% confidence interval. And by default, it is 95. If 99 is, then you could have, you have to change it to 99. But in this case, it's a 95% confidence interval they are asking. So just click that one, press OK. So now what came to you in front of you? This is the descriptive statistics for the mean of differences. And you know that at the bottom, where is the margin of error? At the bottom. Are you able to see the margin of error? Yes, 72.77,255. This value at the bottom is the margin of error. We have done this exercise before. I have highlighted in yellow. And what is the mean? This is the mean value. So what is the, now find out the range, confidence interval estimate. So mean, remember x bar minus e and x bar plus e. So I'm just doing equal to x bar mean value, yes, minus e margin of error. Okay, then again equal to x bar plus error. This is the range 23 to 14,533. This is the confidence interval estimate at 95%, isn't it? That is the part B. Calculate the CI interval for the mean differences in words. So we could say the mean differences of words lies in between 23.47 to 14,533.52. That is the confidence mean interval, mean for the mean differences in the words, because we are using the differences between these words. Part B seems to be clear for you, but what about the part C? Does the 95% CIE confirm the decision made in hypothesis test? So in the hypothesis test over here, what we did using the p value, what conclusion we made? We reject H0. I'm writing here. We have rejected H0. On the hypothesis testing, we have rejected, I'm highlighting it here. Using the p-value, we have rejected H0. And they are asking me, using the confidence interval estimation, does the answer, part C, does the 95% interval CI confirm the decision made in the hypothesis test? So just look at what is the question. In this case, what is your hypothesized mean difference? Remember here, yes, I'm highlighting here all the important here. We have taken this one, hypothesized mean difference equal to 0. I'm highlighting here. So let me highlight it using the different one. Hypothesized mean difference is 0. But what is the range came for the mean difference? This is the range for the mean difference, mean differences. It lies 23 to 40,533. Do you think that the value, the mean difference 0 lies between 23 to 14,553? Does 0, that 0 value, 0 means hypothesized mean difference. Does 0 lies in between the interval? Yes or no? It in between the interval? That is the question. Does 0 lies in between the interval 23 to 14,000? Answer is no. If the answer is no, that means from here also we could say that we have to reject the null hypothesis. So that means reject H0. If the hypothesized mean difference 0 lies in between this interval, if that could be a case, that could be a scenario, in that case we should not reject null hypothesis. Since the 0 doesn't fall between in this range of confidence interval, so from here also we can conclude that we should reject null hypothesis. So this is the different way or different approach towards making the justifying the claim. So let me ask, is there any doubt here? Does all this calculation make sense? The CI estimation, and on the basis of that we are trying to reject. Does that make sense to you? Anyone? Does that make sense to you? Can we do that using the interval? Can we say that reject H naught using the CI estimation? Of course, this is the different way of justifying your claim. Just do it quickly, the exercise number 5, because the answer will be different from just, it will be opposite. That gives you more clarity. Just quickly, can we do the exercise number 5? And we are running out of time as well. So, and that is the last one. Exercise number 5 are the brain volumes of a random sample of twins. Brain volume of twins. Assume that the population of the brain volume follow the normal distribution, and test the claim that there is a difference in the brain volume between the first-born and second-born twin at 1% significant level. Is it a case of independent or dependent? What do you think? Is the case of independent or dependent? The last exercise, we are exercise number 5. The question is the sample is dependent, or samples are dependent or independent? As the twins are, so we can say, you see the data in the Excel sheet and try to see what is given. It's given the data for the first-born, second-born, and the differences is given in the Excel sheet for the exercise number 5. So you could say that these samples, I'm writing here, these samples are dependent. Exercise number 5. The samples are independent. It's not independent. So these okay. So the samples, these samples are independent as the twins are, either paired or matched. So must have some reason. So since it is a dependent one, how to formulate the null hypothesis and alternative hypothesis? The null hypothesis will be same. Mu d equal to 0, means there is no difference between first-born baby and second-born baby. Mu d not equal to 0 means there is a difference between first-born baby and second-born baby in terms of their brain volume and whatever it is given. So again, this is clearly the case of dependent one, not the independent one. So this is the case of dependent one, paired one. So go through the Excel sheet now. Exercise number 5. So first-born is given, second-born is given, and differences is given. So dependent data and paired and matched one. So how to proceed for the, so again you have to, in this question you have to find the same way. First test the claim using the hypothesis testing, then second one is part B is 99% confidence interval, and this again, so go one by one. So the first one, go to the data analysis, t-test for the paired two sample. This is the paired one, dependent one. Paired one, First column, first bond, second bond data. That's it. What is the hypothesized mean difference? Mu d, there is no difference, so 0. I have included level, so click. What is alpha value? In this case, at 1% significant level, so it will be 0.01. Output range, I want it to be here. Okay. Then okay. Result is in front of you. First bond and second bond. Mean value variance is given, observation 10 and 10. What is the degree of freedom? Yes, it's 9, less than 10 plus 10. Okay. Now you got the T stats minus 0.47. So, and let me write the T stats. So T stats is coming minus 0.47. And what is P value? This is the case of again two tail. So what is the P value for the two tail? 0.6466. 0.64. And what is the alpha value? 0.01. Right? Since alpha value is less than, P value is less than or greater than. The P value is 0.64. So P value is greater than alpha value 0.01. So if P value is greater, we should not reject. So what is the conclusion here? Not reject H naught. We should not reject H naught, means we found the support for H naught, and which says that there is no difference. Going back here in the Excel sheet, so using this P value, I'm highlighting here, using the P value is two tail value, what not reject. We got P value which is greater than 0.01. So we could say P less than, so H naught must, so not reject. So not reject. I'm writing here, not reject H naught. I'm writing here, not reject. I hope the things are clear for you, because it's easy. The P value in front of you and alpha value is in front of you. So we can take a decision on the basis of hypothesis testing. We should not reject H naught. That is through the, what is the second stage? Part B for the question. Part B is calculate a 99% confidence interval of the mean differences of the brain volumes between the first born and the second born twin. So it's a CI interval for the mean differences. And what is the difference? The mean difference, what is the differences? We got it. We calculated the differences over here. So in the second, for the part B, what we will do? Just same like the previous one. Go to data, data analysis, and descriptive statistics. They're asking for input range. Just give the difference value and then click OK. Levels, just tick levels. I have selected output range. I want it to be here. All results to be here. Summary statistics, I wanted, yes. Confidence level of mean, yes, I wanted. Is it a 95% or 99 in this case? Read the question, it's a 99%. So I made it 99. Press OK. Now, just like same like the previous one. Now, what is in front of you? The margin of error and the mean value of the differences. So this, yeah, this one is your margin of error, E value. This one is E value, margin of error at the bottom, right? And then you can find out the interval. You know the interval, finding the interval. So now I'm finding the CI interval. confidence interval estimation. Interval I'm asking, trying to get here. So in order to get, so interval will be mean value, this first time minus mean minus confidence level, and then mean plus confidence level equal to mean plus margin of error. Okay, I got this time the CI estimation as, you could read here, 60 minus 66 to plus 49. And what is our hypothesized mean difference? Go back here. What is our hypothesized mean difference? Hypothesized mean difference is 0. Now I will ask here the question, does 0 lies in the interval above? In the interval above? What is the interval on the top? Minus 66 to plus 49. Does 0 lies in between? What is 0? It's a hypothesized mean difference. Answer is yes, it lies. That means we should not reject null hypothesis H naught. And this is the same conclusion we have made it using the hypothesis testing over here. Both conclusions are the same. So we have seen that. Okay, in this case we should not reject, but in the earlier one we have rejected it. Why? Because the 0 was not lying in the range, so we rejected H naught, and that was exactly same as the H naught here. But in the exercise number 5 we have rejected because 0 lies in the interval, so we are not rejecting the null hypothesis, and that is same as the p-value consideration. I think that's all about the exercise 4 and 5. It's your time now, because all the exercises are although over, but I know that there will be a confusion. So or maybe some of you need more clarity. So please go ahead with that and ask. I will be here for another one, like half an hour, to assist, especially those who are not able to understand in a proper way, or especially for those who have further doubts. Some of the things which we are learning will be not a part of your exam, because the Excel sheet will be not a part of your exam. So, but it's better to understand the skills here, some of the concept over here. But initial 2 exercise we do it manually. So manually it's sometimes like it takes time. So that you need to be expertise in that one. But otherwise, using the Excel and getting this stuff and this analysis is a bit easier. So any question from exercise 4, 5, and 3? Exercise 3 was like independent sample, right? New York and Pennsylvania. So different samples we have applied the separate t-test, unequal, two means for with the difference one, independent one. Whereas the exercise 4 and exercise 5 was clearly the case of dependent one, matched or the paired one. In a couple, male and female are the paired or the matched one, or in the twin, the first born and the second one is a kind of matched or the paired. I'm stopping the recording here, and then I will take the questions or the doubt one by one. I hope everybody has marked their attendance on the attendance sheet, because I'm closing that one, I'm saving that one, and on the basis that I will provide you the attendance for today's session.